Hello, everybody. Welcome. Thank you so much for attending our webinar today. This is our second webinar in our series, Assessment to Action. And today we're going to be talking about how you can analyze data from InnerOrbit to identify opportunity areas. Julie and I will go ahead and introduce ourselves. So my name is Emily Miller. My pronouns are she, her. I was a high school chemistry teacher in Minnesota for 10 years. And during that time, I taught in our alternative learning program. I taught regular chemistry. I taught honors chemistry. So I had a lot of opportunities to try a lot of different strategies with a lot of different kiddos. I was also a NGSS pioneer and advocate within my science department. And I also got to be a PLC lead. And I got to lead a lot of data-driven dialogue, which is all our webinar is about today. So I am thrilled, if you can't tell. And now I have the wonderful opportunity to partner with districts to help them implement InnerOrbit. And my new exciting thing is in my house, we are now buying fresh coffee beans and then we're grinding them and then we're brewing our coffee right away. And I might have just ruined myself because it is so delicious and so much fresher. And that has been my new fun adventure. Julia, do you want to introduce yourself?
Of course, and thank you, Emily. I know you really like coffee. I do not, but some people are right, some people are wrong, and that's just the way it is. Well, thank you so much, everyone, again for being here. My name is Julia Mota. I was a teacher and a tutor for elementary students in the Dominican Republic for a little while, and then I passed on to support teachers and districts with their NGSS implementation. I've been doing that for the past 4 years or so. My job is to partner and provide guidance to schools and districts implementing assessment in their NGSS instruction, specifically with InnerOrbit. And I actually think matcha is better than coffee. It's delicious. And I know it says I'm obsessed with severance there. I'm also obsessed with severance. But yes, I know it's been a week now, but I'm still obsessed with it. Cool. And now today we're going to talk about analyzing data to identify opportunity areas. Our objective for today is to provide tools to analyze and interpret data to identify these opportunity areas, as the name of our session is. We're going to be here for about 30 minutes, and we have a rough agenda for you. We're going to go about what is InnerOrbit first. We're just going to talk about that for the first 2 or 3 minutes in case you don't know, so you have a little bit of context. Then we're going to talk about InnerOrbit's alignment with state test data. We talked a little bit about that in our past webinar, but now we're actually going to focus on how to determine your state test cut scores. We're going to how you can align these cut scores to your assessments, and then we're going to revisit the findings of these case studies that we went into in our past webinar. Then we're going to do a data chat model where I'm going to play an admin and Emily's going to play a teacher. And we're going to go through the dimensions data, real data from these assessments, by the way. And we're going to go through the different reports that we have on InnerOrbit. First, the dimensions report, then the assignment report, and then finally, the district report. And then we're going to share some resources and wrap it up. I know you have a lot of questions like Janine here, but hopefully we can answer those soon. And the first question I'm going to answer is, what is InnerOrbit? Now, the first thing that InnerOrbit is phenomena. And on InnerOrbit, we have from 4 to 6 phenomena for every single performance expectation. And the idea here is that you have plenty of phenomena to use throughout your instruction so that students have that opportunity to practice that transferring from what they learn in class into these novel scenarios that they've never seen before, which at the end of the day is the heart and the end goal of sense making. We also have questions. And instead of just going into those big rigorous questions that we've seen on state tests, and that we know that these questions actually meet the level of rigor of the performance expectation, we actually have questions that scaffold up. And we go from the very basic prior knowledge, even on grade level knowledge, one-dimensional questioning, to those big 3-dimensional questions with different scaffolds that build up students' performance to meet them where they're at. We also have different reports, and we're going to dive into those today. We're going to understand how you can look at data on InnerOrbit, and also how you can think about this data in your district to make shifts, and how to kind of like identify what might be some next steps with your data. But on InnerOrbit, you can see the level of detail of not only seeing, oh, students are struggling with a specific SCP or with a specific DCI, but you can see within which grade level band they're struggling with and within which element of the SCP, which is really actionable for you to understand what are the next steps in instruction that we need to take. And then finally, professional learning. You're here in this session. We host these sessions almost every 2 weeks, mostly. In our sessions, we also partner with our districts to provide professional learning and tailored professional learning to them. As you can see here, this is our colleague, Erin. She's amazing. And then we also have, I'm going to drop a link in the chat in case you would like to meet with us and talk a little bit about what InnerOrbit is. And if you're interested of maybe trying this out in your district to see how this can benefit your teachers and students. Now, without further ado, let's actually go into the content of our webinar today, which is all about InnerOrbit's alignment with state test data and how we can use that data to make informed instructional decisions. Over to you, Emily.
Thank you, Julia. So if you were with us in our first webinar in this series, this initial part is going to be a little bit of a recap of the research that we did within InnerOrbit, but then we're going to be expanding on that shortly thereafter. So what was this research project that we did? So InnerOrbit, our mission has always been to support districts and educators in implementing NGSS-aligned instruction and assessments that truly fit their local context. One common theme that we were hearing from our partner districts across the country is that they wanted to help prepare their students for their state science tests while staying true to three-dimensional science learning. So we asked ourselves a key research question. Do InnerOrbit summative assessment scores align with NGSS state test proficiency levels? This research project was designed to dig into that exact question by analyzing student performance across states, grade levels, and assessment types. Let's take a look at what we found. The results of this study were exciting, and honestly, they were really affirming. We found that schools and districts can confidently use InnerOrbit assessments as a reliable way to measure progress towards NGSS proficiency, especially when preparing for state tests. What this means is that the 3D data teachers are gathering from InnerOrbit doesn't just support instruction, it also aligns with external measures of student performance. In other words, using InnerOrbit, educators can track student mastery of NGSS standards while also building readiness for their state assessments. So just a few things about this research project. So in order to be involved within this case study, we were only looking at districts that collected data within the 23-24 school year. And that assessment that we looked at had to be a common assessment that included at least 33% of the student population within that tested grade level. So if we were looking at 8th grade, at least 33% of the students of 8th graders within that school had to have taken that assessment. We also only looked at assessments that had auto-scored 2D and 3D questions. So nothing that was teacher graded, so there wasn't any bias, and only 2D and 3D questions, so they were truly summative. We also only looked at tested grade levels, 5, 8, and 11, because usually across the country, those are the most commonly tested grade levels. And we also looked at states that have had an NGSS assessment for at least 3 school years. So we know that some states are at different adoption levels of the NGSS, so we only looked at ones that have been doing it for at least 3 years. So what that led us to is we ended up looking at 3 different districts across 3 different states: Oklahoma, Connecticut, and California. And what our data showed is the data showed an average alignment of 97%, with no alignment less than 90%, highlighting a strong relationship between InnerOrbit summative assessment scores and state test outcomes. So to zoom in a little bit closer here, because I know there's a lot going on with this bar graph, what you can see is within each of those different proficiency levels, so level 1, level 2, level 3, and level 4, what we saw is, for example, for Oklahoma 11th grade, 98% alignment was given within level 1. So that means within 98% of students who got a level 1 on the Oklahoma state test, they got a level 1 on our InnerOrbit assessment. So this is really telling us that InnerOrbit assessments are not only aligned, they're also predictably aligned, regardless of the grade level or the geographic region. That kind of consistency is exactly what districts need when they're trying to support all students and make data-driven instructional decisions that connect to high-stakes testing. So what we wanted to now kind of dive in a little bit further from our first webinar is to show you essentially how we got those numbers in order to generate those graphs. And so we're going to be looking in a deep dive into our California district and into the California State Science Test, which is also called the CAST. So our California district, we specifically looked at the grade 5 and the grade 8 test. And this is from the California Education website. As you can see, the minimum score a student can get on the 5th grade test is 150, and the maximum score they can get is a 250, and then 350 and 450 for 8th grade. So both of these tests have a score range of 100 points. Then you can dive a little bit deeper and see the score ranges for each level. So level 1 would be the student has not met the standards. 2 would mean that they have partially, nearly met the standards. And 3 is what we consider to be proficient. So they have, in fact, reached the standards. And then a level 4 is they are exceeding the standards. So this is, again, for the 5th grade test. And this is showing the range that they would need to get within that score of 150 to 250 to get those different levels. So then what we did is we figured out the minimum score they would need to get in order to achieve each level. So to get a level 1, they'd have to score minimum 0 points. In order to get a level 2, the minimum is 29 points, 64 points for level 3, and then 81 points for level 4. Now remember, this is on a 100-point scale because it goes from 150 to 250. So there's 100 points available to score. And so in order to get a level 4, they have to score at least 81 of those 100 points. Or another way to think about it is they have to score at least 81% in order to get a level 4. So what we did is we essentially took those levels that they give us on state science tests and we turned them into percentages. And then we plugged those percentages into InnerOrbit. So InnerOrbit naturally breaks down all of the data into 4 different levels. The data on InnerOrbit automatically goes from a 0% for level 1, 20% for level 2, 40%, and then 60%. But you can change and manipulate those numbers to whatever you want them to be. So what we did is we changed and manipulated them to match the percentages from the CAST. And we looked at that with their 5th grade science benchmark pilot. So if you look, 619 out of 677 students took this 5th grade benchmark. What we can then do is we can then generate what percentage of students were able to then get each of those different scores. And then we can compare that to how this district did on the CAST. So as you can see, we've got the percentage for level 4, level 3, level 2, and level 1, given that data from InnerOrbit. So for example, 109 students were in that level 1 on the InnerOrbit assessment. And if 109 out of 619 students got a level 1, that would be 17.6%. And then if you look at the graph, 10.39% of students got a level 1 on the CAST. So if you just kind of briefly compare these numbers here, they're all pretty close with really no more than a 10% difference. And we have a distribution chart on the next slide, which kind of shows you a little bit more of this difference. So as you can see, the biggest discrepancy was with level 4, and then the next biggest discrepancy was with level 1. But within 10%, students were within 10%, how students did on the InnerOrbit assessment reflects how they then did on the CAST assessment. I want to show you another quick example with 8th grade. It's going to be the same process. So 8th grade, the minimum score was 350, max score 450, still a total of 100 points. We again looked at the minimum amount of points out of 100 that students would need to get to score each level, and then translated that into a percentage. We are then able to take these percentages and able to put them into InnerOrbit, into our automated level 1, level 2, level 3, level 4 system. And then we can look at the number of students who took that assessment and divide each amount of students by the total amount. So for example, 242 students got 83% or higher, which would be considered a level 4. And so that would translate to about 18.5% of students getting that level 4 amount. And then on the actual CAST assessment, 20.79% of students got that level 4. And then you can look at this distribution chart again for this 8th grade assessment. So we wanted to do a deep dive with you all on these cut scores and examples and how we did this process, because any of you can replicate the same process with your state. So you can look up your state's cut scores, figure out the percentage, and also input that into InnerOrbit. Now, the next big part of this webinar that we're going to be diving into is the amount of data that you can get from InnerOrbit in comparison to state tests. So this is just California and the CAST, but we've seen a really familiar theme across other states. So with the CAST, you can see how students did as far as what percentage got a level 1, 2, 3, or 4. And then you can see what percentage of students are above the standard, near standard, or below the standard for the 3 main domains within science. So life science, physical, and earth and space. And this is it as far as data that you can then take as a teacher or as administrator and then bring back as far as how to move forward, right? Ultimately, our goal as educators is to have all of our students be successful. But with this data, it's hard to know exactly how to do that. So we might see that students are doing better in life science than they are in physical science, but that's a very, very broad number and a very broad problem to look at. So now what we're going to be doing is we're going to be taking a deep dive into the detailed reports that InnerOrbit generates. Because if InnerOrbit's assessments are on average 97% aligned with state science tests, the detailed data you can get on InnerOrbit, in theory, could help inform instruction to help move the needle on those state science tests. So for this district level data chat, Julia and I are going to do a little bit of role playing. And Julia, if you want to go ahead and explain how we're going to do this, we'll go ahead and dive in.
Of course. Thank you, Emily. And thank you for diving into those cut scores. Now we're actually going to dive into a real data chat model. And this is real data from one of our partner districts, and this is how it's going to work. So I'm going to be stepping into the role of a district admin, and then Emily will be playing the part of a 5th grade science teacher. And together, we're going to look at real student data through the lens of the NGSS dimensions and make sense of what it's telling us about our instruction, about student thinking, and what are the next steps that we're going to take. Now, I also want to say, we want to give you the chance to make some observations too. So as we move into the data slides, feel free to drop your thoughts in the chat. We'll be reminding you to drop them. But once we've heard a few ideas, then Emily and I are going to have those conversations that happen when teachers and district admins sit down together to look and unpack what the data means. Now, for a little bit of context, before we dig into any data, we're going to set the stage here. And this data comes from a large suburban district in California, same case that we were looking at. However, in this study, I do want to mention, we also looked at Connecticut and Oklahoma, but this also can apply to other states that also have NGSS aligned assessments. This data also comes from a large suburban district in California, as I mentioned before. They just began partnering with InnerOrbit this school year, and they're using our platform across grades 3 through 12. And what we're looking at today is data from a 5th grade mid-year benchmark, which was a summative assessments that focused on priority standards from the first half of the year. And these assessments had 13 questions with about 1 to 2 questions per standard. And it's giving us a quick but focused snapshot of student understanding across a handful of NGSS performance expectations, priority standards. Cool. Now, let's jump into the first step of our data chat, which is observation. And at this point, we're not making any judgments or trying to figure out why students performed the way that they did. We're just looking at the data and noticing if there's a pattern. So here's the questions that we want you to consider. And we're going to give you a minute to write those down, the answers down. So where did students excel and where did they struggle? And we're going to start with these observations with what we call this our dimensions report. And this is a report on InnerOrbit that breaks down each of the 3 dimensions and their performance expectations and everything that's stacked there. So go ahead and drop your observations in the chat. Okay, so Kimberly is saying in the chat that when we look at the cross-cutting concepts, students excelled on cause and effect. However, they struggled with scale, proportion, and quantity. Jennifer It's also saying that they struggled with scale, proportion, and quantity. Shane says that they struggled with the SCP of developing and using models. And that looks like that's what the SCP that they struggled the most with from this snapshot. And thank you. If you're still writing answers here, then please keep doing so. In the meantime, Emily and I are going to start our role play. Now, Emily, let's take a look at this dimensional breakdown, right? So I see, starting with the DCIs, I'm noticing that students did really well on PS2, which is motion stability, at 78%. But with PS1, matter and its interactions, they came in a little bit lower at 45%. What do you notice?
So when I was looking at the cross-cutting concepts, my eye immediately went to the orange with that scale, proportion, and quantity. And noticing there was a really big discrepancy between that CCC, the cross-cutting concept, and cause and effect, which was at 78%.
I definitely agree with that. And I think that with the SCPs, we can see a similar story, not as a drastic with the cross-cutting concept, but with planning and carrying out investigations, we see that they're up at 78%. So they excelled with that, which is great. But with developing and using models, that seems to be an area where students have more difficulty. And they're sitting right now at 47%. Now, stop role play. With this dimensions report, what we want you to see is that you're getting a broad view of the data. So we're going to take one of the standout observations and dive a little deeper into it. In this case, since the SCPs tend to be a useful area of focus and growth, then let's start there and let's take a look into the highest and lowest scoring SCP, which are planning and carrying out investigations and developing and using models. Let's look at the detail of that. Do you notice anything interesting here, Emily?
So one thing I'm noticing with developing and using models is they're doing similarly on two different aspects of developing and using models. So it looks like they've been assessed on having to develop a model using an analogy, example, abstract representation, and they've also had to develop or use models to describe or predict phenomena. And they seem to be struggling similarly with both. And oh, I was about to do an analysis, but I'm not supposed to do that. I'm like jumping the gun. And that's what's nice about this part is you always just want to start off with observations because it's easy to just like go down a hole and then forget to kind of look at the big picture. So that's one of my observations, Julia. What's one of yours?
Well, I'm noticing a big contrast here between these two SCPs, but on focusing on where students excelled, in this case, planning and carrying out investigations, I see that they most specifically did really well planning and conducting an investigation collaboratively to produce data to serve as the basis for evidence. So that's a very, very specific element that they did really well on, but they haven't necessarily, we don't know about the other elements of this specific SCP yet.
One thing that I would love to do is I want to see maybe the questions that they struggled on specifically, because right now we are just looking at data for that one benchmark assessment that was only 13 questions long. And so I would be curious to see what questions we're assessing, developing and using models, and maybe get a better idea of why this was a struggle for them on this particular assessment.
And that's actually our next slide. Now, if you want to use, like when we see this data like this, we're like, I want to dig deeper. I want to understand a little bit better. Our assignment report give us a very specific look into an item analysis of each question. So we pulled up 3 questions that were given on the benchmark that assessed specifically this SCP. And now that we're zooming in here, do you notice any patterns, Emily?
Yes, because we're still at the data observation part of our data chat protocol. Again, you want to try to withhold any judgment and just state the facts first. And then once you have all the facts in front of you, then go ahead and we can start into step 2. So my initial observations, now that I have a chance to actually look at these questions, is on the 2D question, they did better than on the 3D questions. So that 2D question is only assessing 2 dimensions, where the 3Ds are assessing 3 different ones. So that's interesting. The other thing I noticed is they did worse on that middle question, which was looking at a life science standard. than they did on the bottom question, which was looking at an Earth and space science standard. So now that I've had a chance to look at all of this data as a teacher, I'm really curious to actually see what these figures are and actually see what these models are to see if I can kind of have an idea of what part of the question they struggled at. Especially, I want to know what other options they were picking. Like if there was a really common distractor, that might be able to help me figure out what part of the model might have been hard for them to interpret.
So since this was the assessment that we created at the district level and students took it, then I would love for us to move into a little bit more of a data analysis when we look at these questions. So now that we've taken observations at various levels, let's dive deeper into the analysis part of the data chat protocol. And this is when we can start. Now we're allowed to make assumptions about why students may or may not have struggled or excelled with different areas and what students may or may not understand. So as we dive into these questions next, before we even do that, to understand student performance with these SCPs and understand what the data is suggesting, we're going to look at a specific model and analyze the questions. But before we do that, is there anything that we see here that the data may be suggesting after we've looked at the dimensions report and the questions right here? Feel free to share your thoughts in the chat. Okay, so Kimberly is saying, I don't like the phrasing of the 3D sense making question. What were the answer choices? And that's really important because as we looked at this data analysis, what figure? So Shane is saying, what figure was connected to the first 3D sense making question? And this is really important for us to actually take that step and look at these questions deeply, look at the phenomena, look at those models to understand if this is an isolated event before we make these assumptions and these suggestions, actually, if this is an isolated event or if there's a disconnect or discrepancy between what we see in the classroom versus what we're seeing in these results. Now, Emily, would you want to guide us through your analysis about what these questions may be telling us? And this is the first question, the two-dimensional question here.
Yes, thank you. So Kimberly and Shane, I was right there with you. Like when I had my teacher hat on, when I was looking at that analysis, I was like, I can't really analyze this any farther until I have more information. So this question, so look at figure 1, which living thing needs the same types of food resources as sea urchins? So the phenomena here is looking at kelp. So kelp is a type of seaweed that can grow very large, creating an underwater forest-like environment. And so figure 1 is showing a food web of how different animals interact within this ecosystem that kelp also interacts with. So the correct answer to this question was snails. And that would be because snails and sea urchins are kind of on that same level within the food web. So they're both consumers and they're both consuming kelp. So when I'm looking at this, I'm really interested to see that out of the 3 distractors, there's one that students were picking more often than the other, which was kelp. And I want to be really clear before I keep diving into this analysis a little bit further. I was not the teacher who gave this assessment, and I was not the teacher who did this instruction. So I am inferring if I had taught this, knowing my little 5th graders, what they might have gotten hung up on. So what I would maybe imagine is this idea that maybe my students are really thinking about this as the entire ecosystem, and they are understanding this energy flow. So this idea that the energy and matter that's going into the kelp, what goes into the kelp then also goes into the sea urchin. So which living thing needs the same types of food resources as sea urchins? Well, since the sea urchin is eating kelp and everything that the kelp consumes powers the sea urchin, maybe that's what they were thinking about. So they were kind of thinking about it more big picture rather than understanding that snails are also on that same tier. Those that are picking sea lions and killer whales, those are like larger consumers higher up on the food web. And so at least for me, I don't know if this was necessarily an issue with the model with the food web, rather than maybe understanding like how sea urchins and how these different things work within the ecosystem. That's just my idea there. But I'm curious to see what the other models were in the other questions to see if this was a theme throughout. So the 3D question that they ended up doing the worst on, the one that they ended up doing the worst on is this one right here. So this was a 3D question. And the question asked, a classmate says that sea lions and sea otters need plants to survive. Do you agree? So use figure 1 to help you. And so in this case, they need to look at the food web and make a deduction. Do sea otters need plants to survive? The correct answer is yes, because the food they eat depends on plants. So if they are going to consume sea urchins and shellfish, and those things need to eat kelp, ultimately the sea otter does rely on it as well. So it's curious to me that the most common distractor picked was no, they only eat other animals. To me, that's them reading the model, right? So they're looking at the model here and seeing what is pointing to the sea otter. And they're not seeing that the kelp is a critical part of this ecosystem and would have those like rolling effects as a result. And so again, when I'm looking at this and I'm looking at this idea of the SCP developing and using models, I'm starting to wonder if the developing and using models, as far as looking at the food webs, if that SCP maybe wasn't as much of a struggle. Because I'm not necessarily seeing a lot of inaccuracies with like reading the food web, but maybe it's the idea of how this plays into that larger system. So maybe a little bit more with the CCC in this case. But again, I want to see what that third question was like to see if my idea tracks. So this one is on a totally different phenomena and on a totally different DCI. So this is on Earth materials. So this is Earth space science. And this is all about rain shadows. And so my question is, while observing figures 1 and 2, what effect does the rain shadow have on the geosphere and biosphere in that area? All right. So one thing I'm noticing right away is that this question is having them reference 2 different figures. So that's 2 different things that they need to kind of combine together. This also is involving them to have some key vocabulary words down of geosphere and biosphere in order to be able to answer this one correctly. But what I'm noticing here is they really need to be able to look at that first figure and see where that rain shadow is falling. And so if you look at figure 1, the rain shadow is on the other side of the mountain as the rain cloud. And so that's actually not getting any of the moisture. And so that's where it would be dry. And all of the distractors, for the most part, are being picked equally. And so I don't know if it's necessarily like a common misconception that's pulling students away from the correct answer. This might be them having a hard time looking at this figure and interpreting what's going on with it. So when I'm thinking about this SCP of developing and using models, as a teacher, what I'm seeing is maybe we do need to look at interpreting models more, but maybe the focus isn't necessarily on food webs as much as it might be other models within like weather and climate and the earth. And so that's essentially where my analysis might be leading me. So as a teacher, I wanted to dive really deep, get really specific. And the beautiful thing about InnerOrbit is that you can do that. So you can look at these items, see how this translates to that dimensions report. So get that big zoom in deeper, zoom back out, and see where these are connected. But I know that Julia, with her admin hat, probably wants to look at something a little bit different.
So talking about zooming in and zooming back out, I would love to zoom back out a little bit more. So now that we know exactly, we've seen some distractors, we've seen specifically where students struggled with these questions, let's actually look at the whole district. And let's focus on comparing these different schools with different SCPs. As an admin, I want to take the opportunity to zoom out, again, as I mentioned before, and look at how specifically developing and using models is playing out across different school sites in the district. And on these charts, as you can see, each row represents the schools and the columns highlighted show performance. And in this case, the one highlighted here specifically is tied to modeling. So take a moment to scan the data and drop your thoughts in the Zoom chat. So do you see a pattern between different school sites is what we meant to say here. So if you see a pattern, please drop what you see in your observations in the Zoom chat now. Yeah, so Shane is saying that all schools are doing wildlife planning and carrying out investigations. And this is also something that we wanted to highlight because we also want to celebrate where our students are excelling. And in this case, all of our schools are really excelling with this specific SEP. But when we go back to our focus SEP for this session, developing and using models, there are some things that we can see. Yes, there's a struggle. So okay, all the answers are coming in. So Shane says that there's a struggle and inconsistency with developing and using models. And let's see what School 4 is doing. I love that. So my question might be, Gail says, my question might be, what is School 4 and 9 doing? So School 4 was the only one that excelled developing and using models. So we are all kind of on the same page, right? So what happened with School 4? What is going on? And that also takes us to our next kind of part of the data chat protocol, which are the data implications. So what are the next steps that we can take with our students as a result of this analysis? And taking a look at all of the snapshots, little snapshots that we saw, the dimensions report, the assignment report, and finally the district report. So bringing all this back together, maybe as a district admin, my next step would be to connect with 5th grade teachers at school number 4 to understand what strategies they're using with developing and using models to see if we can replicate the same thing across different schools in the district. Maybe I also would want to understand possible professional learning opportunities around this specific SEP. Maybe it would be helpful to host a session about scaffolding this specific SEP of developing and using models. And this might be a useful resource for elementary teachers across the whole district. Now, we're going to get to those questions about demographics in a second. But Emily, do you have any next steps that you would take from this whole data that we've seen?
Yes. So putting my teacher hat on, next steps for me after looking at this data would be I would want to ask my students some more questions about modeling, because in particular, those 2 questions with the food webs, I don't know if it was the modeling piece with the food web that was getting them hung up. And as Kimberly noted, there was some confusion with potentially with the phrasing of the question and what was being asked. So a next step for me would maybe be a reassessment in terms of looking at assessing the SCP developing and using models in a different way and seeing if those patterns and trends are still popping up. Another thing I would want to do is have my students interpret different types of models. Because as we know, like a food web model is really different than like looking at a climate model or looking at an atomic model. And so seeing that skill play out in different areas, I would be curious if there's some models they're struggling with more than others.
And then as next steps for data implications, there was somebody, Kimberly in the chat is asking, is demographic information consistent throughout the schools? And that is a great question when we're reflecting about data. And I want to highlight that this is our 4th part of our 4th and final part of our data chat protocol. And here is all about reflecting, right? Not just on what the data is telling us, but what it's revealing also about our teaching and assessment practices. So there are a few assessment questions that we would like to consider. So first, what questions about teaching and assessment did looking at this data raise for you? So for example, if we're giving students enough exposure to modeling tasks, as we were saying before, in a way that mirrors how they appear on assessment. So are we doing the same things in the classroom that we're asking students to do in these assessments, or are these 2 separate things? Are there any discrepancies on that? Did any questions of equity come up? And even though we can't necessarily disclose right now, and we could share in an email, Kimberly, like what the demographic data of this district is, but we cannot really disclose who this district is at the moment. But when we talk about equity, we need to think about who is performing well and who isn't in our classroom. Are all students getting equitable access to these sense-making routines, the science practice, and the support that they need? We can also ask ourselves, what additional analysis would we want to do and why? So if we want to dig deeper by classroom, by demographic group, or by standard, if we want to filter the data even more, those are things that we can definitely do with our reports. And then finally, what would you want to try out in your classroom as a result of this data? So Emily already went into this reflection before, but this is the big one, really. Like this is where we would want to spend the most time on. So is there a practice that we would tweak Would we call up the school number 4 teachers to understand what they're doing? Is there a new routine that we're going to introduce, a new different practice, or a change on how we're using models in instruction? So all these are questions that we would ask if we were really doing a data chat within a district to understand what would be next steps, or within a school, what would be the next steps, and to consider those. Now, what I'm going to do is actually, Emily is going to share that link in the chat. And if you want to use the same data chat protocol in your district, you can do so. Just as a recap, we had the data chat protocol had 4 main steps. The first one was data observations. It's supposed to take about 7 minutes. Then data analysis. Data implications is the one that's going to take you the longest, because that's when the real understanding comes. And then finally, the data reflection, if there are different things that we can do. So Emily just dropped that link in the chat. We'll also share it in our follow-up email tomorrow. But if you want to take a look at what that looks like and use it within your districts, then feel free to do so. And now, I know we went over 15 minutes, but we're going to wrap us up today. And thank you so much for being here. Thank you so much for engaging with the content on this webinar. And thank you so much for always being here, to some of you. Today, we did so much in just over 45 minutes, actually. We went over all these things together. And now for next steps, the next webinar of our series is going to be on strategies to improve those opportunity areas. So now that we've discovered what those opportunity areas are with our data chat protocol and with our data analysis, we're going to see what are some things we can implement in our classroom to make sure we address those and we support our students in the way that they need. So that link is in the chat right now. If you would want to talk to us about maybe setting up a pilot or finding time for us to talk, if you are still not using InnerOrbit, feel free to also click the link in the chat that Emily's going to drop. And either Emily or I will help you set up a pilot. We'll help you understand what are the goals for that, or what would you want to achieve with your students. So we would love to chat with you soon. And you can also follow us on social and subscribe to our YouTube channel. If you like this kind of content, we are always uploading videos and uploading different things to our YouTube channel. So if you want to keep looking at this type of content, feel free to go ahead and subscribe. If you have any questions or comments, you can always email us. Thank you so much, everyone, for being here, and we'll hang out for questions if you have any.